Arcturus Tukitana Lunar Student sends warm greetings. In this video, we are going to thoroughly analyze and present an optimization and performance report pertaining to our latest video game release. So, what we are going to present here are the critical findings and optimization strategies for the stability of FPS and reducing CPU load in the project. The problem summaries we identified were primarily related to the user interface, specifically focusing on the UI within Render, Canva, and Layouts. Additionally, there were concerns regarding lighting issues, particularly in physics relating to event collisions. In Grabber Collector, the main issues were centered around the creation and description of temporary objects. Well, let's go for optimization point. In Optimization 1, we observed the challenge with ASV interface. It highlights the issue where the canvas frequently experiences spikes in activity when moving both static and dynamic elements, impacting the overall performance of the system. What is the division? What is the solution? To optimize performance, one approach is to divide the large canvas into several smaller canvases and minimize layout blocking caused by static elements. The result would be the reduction of UID spikes, leading to improved performance and greater stability of FPS in scenes with full interfaces, enhancing overall user experience. Optimization 2 involves constant recalculating for improved lighting efficiency. So, what could possibly be the optimal solution here? It would be beneficial to activate light baking in the scene in order to optimize rendering and decrease reliance on real-time lighting for certain objects. The results would be the elimination of periodic peaks, leading to a more stable and predictable trend over time, ensuring better forecasting accuracy. The Optimization 3. The physicists. What was the problem? Activate collision events to detect contact with dynamic voids. So what would be the solution? The optimal solution would involve minimizing superfluous colliders, streamlining the cognitive abilities of the collider, utilizing bot sets for spray, boxes, and biospheres, and decreasing regivoilative elements. The result would be a reduction in physical calculations and an improvement in overall engine performance. Now the last, Grabber Collector and memory. Before the problem arises, the Grabber Collector's speeches, artistic creations, and continuous detailed descriptions of ephemeral objects create pauses that disrupt the flow of the narrative frame. The solution, the oil object reduces instantaneously, reuse pre-installed objects, and optimizes script to avoid allocation per frame. The result would be a noticeable improvement in performance with more efficient memory usage, leading to smoother execution, free of interruptions, thanks to the effective garbage collection process. Here I have some images showing the before and after. Here in the first image, we observe some exceptionally high peaks in the CPU, reaching durations of up to 45 milliseconds, indicating significant activity. Greater memory usage in GC peaks due to increased complexity, and higher peaks in triangles and batches, impacting performance and resource allocation. After doing the optimization, this is how it looks afterwards. The CPU is more stable with a maximum response time of 16 milliseconds, resulting in reduced memory usage. Additionally, there are fewer triangles for smoother performance and more stable surface bumps. Thank you very much.